expectation what the future of web frameworks look like. And I don't mean purely looks. If you've seen Solid at all, you might be thinking, oh, it looks a lot like React. And that would be fair. But there's some big differences that I'm going to show today. And that's why I'm not going to dwell so much on trying to sell you on Solid's many features, nor am I going to try and sell you on how performant it is, at least using micro benchmarks. No matter how dominating a display on client or server, I mean, it's pretty much a meme at this point. People are just like, blazingly fast. So I'm going to say Solid's really fast, and we're going to move on from there. Anyways, who am I? My name's Ryan Carniato, as I said before, and I'm the creator of SolidJS. But I've been doing web development now for like 25 years. I lived through, table soup, and I worked in ASP.NET, and Rails, and jQuery, and it wasn't really until the 2010s that my passion reignited for front-end JavaScript. I'd gotten my start building band websites in the late 90s, and it was just, whatever you could view source. In any case, I worked at a startup through the 2010s, and that's when I started Solid back in 2016. So it's been almost 7 years now. And for a few years, I worked eBay on their JavaScript. For those who don't know, eBay runs JavaScript full stack. They also have Java for their API services, but the web rendering is all done in Node and JavaScript front ends. And recently, I'm now working at Netlify, working on open source. All right, with that out of the way, let's get started. I wouldn't blame you for thinking this is a reenactment maybe of like a Twitter discussion about JavaScript frameworks. Like, it is interesting though. The last couple of years, people have actually been pretty open to the possibility of having new frameworks again. There was a time, especially around the time I started Solid, 2016, 17, 18, where people were really against the idea. It was like I was bringing a blight on the world. It's like, no, why do we need another JavaScript framework? You might still be thinking that, but I'm going to show you a bit more what's going on, because one thing that's changed in the last couple of years is people are kind of willing to consider that there's a new paradigm shift coming, right? You can kind of feel it in the air. That's why new frameworks are showing up again. And interestingly, it's kind of accompanied by this thinking. I've found that there's this vision, especially in the front end world, where they're picturing React coming in, what is it, 10 years ago? I think that React has celebrated its 10th birthday, and came in, conquered jQuery in one stroke, basically moved web development forward years. But that's not really how it happened, or at least that's not how I remember. I think history is kind of written by the victors. And I remember the time before React as a time full of a lot of innovation, actually. People were trying new ideas. They might not have figured out how to put them quite together properly, but stuff was going on. And I think we're in that sort of time period again, honestly. So here's my big headline. Modern front-end development for years has been about components. Class components, function components, option components, even web components. And for good reason. Components are these essential building blocks. They make our app modular and composable. And in a lot of ways, in the front-end JavaScript world, we owe React for that. However, in almost every JavaScript framework, components have runtime implications. The update model and the life cycles are tied to them. And this basically led to two views of the world. Essentially, either you have some kind of top-down diff, like a virtual DOM or tag template literal, or you rely pretty heavily on compilation. But both of these are based on these components that rerun top-down. And the thing is, when stuff runs top-down, at a certain point, you've got to just ask the question, what work you do matters, right? When to memoize. There's this great talk from Shun at ReactConf 2021 that actually addressed this topic. And I'm going to use some React code. Hopefully people are familiar with React. Everyone familiar with React for the most part? Okay, well, you might picture in a modern framework that you declare some state, and when you update something, you might have a click handler. That's what that onChange is doing, essentially checking a to-do. And then you map over the to-dos in the middle, and that's how you build an app. The problem is that if any state in this component changes, the whole thing reruns again. And that in itself isn't a problem, because we have a virtual DOM, something that will kind of protect us. It's a lot cheaper than making DOM nodes every time. But you might still want to optimize. And as you start adding features, maybe you need a filter or set a theme color. You start passing props in from above. And then next thing you know, you got all these detached pieces of state. And then you're like, OK, well, how do I make this not just run all the time? Well, there's an answer to that, too. Use callback. Use ref, dependency raise. Use memo, react.memo. A bunch of primitives designed to tell your component exactly when to run. And again, there's nothing wrong with this. This will update exactly the right amount that you want it to. But I'm going to argue that this is a bit of departure where we started off from. So what can we do about this? Well, I don't know if anyone's seen Svelte, but the kind of running gag here is that you just use a compiler. Like, why write all this code when you can just write your intent directly? We're going to hold that thought for a moment, because we will get back to it, trust me. Now I'm going to show you way too much code. Don't try and read this. Just listen to what I'm saying for a second. This is what a compiler might actually output. This is from that same React conf. And Svelte actually doesn't work all that differently from this. The idea is a compiler could look at every decision point in your code and have some kind of cache. They call it memcache in there, so don't focus on it too much. But there's a commonality here, right? It's a bunch of shallow checks at every decision point that rerun when your component is marked as needing an update, right? So basically, the flow is your user or an event updates some state. We mark the component as dirty, we rerun it. We check against some memoized cache values that reduce work. But it doesn't really matter if the original code called a function named setState, like in React, or an assignment, like in Svelte. It's kind of actually the same thing. So what if we didn't? What if we only ran what was needed to be run and didn't rely as heavily on compilation? What if components didn't dictate didn't dictate our performance of our web application? And to do that, I need to go back to the beginning. I mean, really the beginning. This is basically Hello World. It might have been the first program you ever wrote. You learn you can set a variable, you can log it to the console. And it isn't very long before you realize, well, you can just set that variable to a different value, log it to the console again. Why am I getting such an inane example like this? You'll see in a second. Then the developer is like, OK, this is a lot of repetition. Let's extract that out into a function. Now we're dry. And we're kind of on our way. Except there's something fundamental here. What if we just want to greet our friend whenever we set the name? And for that, introduce another concept. One of my favorite concepts, which is reactive programming. It's really at the heart of almost all UI for frameworks. You want the user interface to stay in sync as the user interacts with it. The way I think about it is like a spreadsheet, right? In a normal assignment represents a moment of time, right? We see that A equals B plus C, for example. And if you change B or C, you have to assign A again to get the updated value. But what if the relationship held instead? What if whenever we changed B and C, A also immediately updated? That's basically what reactive programming is. And I've been talking a lot about something that I call fine-grained reactivity, which is a form of this kind of reactivity. Some people might have heard of stuff like RxJS or RxJava. This is a little bit different. It's based on 3 primitives. It's based on an atomic atom, which we call signal. It's based on derived state, which some libraries call computeds or memos. And then it's based on a third primitive to do side effects. In frameworks, we like this because it's pretty simple, right? Relationships are set once and executed. You describe the behavior rather than the implementation. And it's very composable. You can just wrap these things. And it's fairly low on concepts. What we're really doing, and this probably makes more sense to React developers, is like you might feel like you've seen these concepts before. And from a language perspective, you can consider this kind of somewhat similar to React hooks or Svelte dollar signs, but both of those are tied to the components, which is really what I'm trying to get away from today. And these composition patterns I'm talking about existed in older frameworks. This goes back to actually the 1970s. There is a lot of research into this kind of synchronous reactive programming, stuff around digital circuits. And even if you look at like a hardware design language, there's a lot of similar concepts of this idea that when you apply changes, they apply everywhere at the same time. Stuff like VHDL or whatnot. In JavaScript, early JavaScript frameworks like Knockout.js implemented this kind of approach. And it's really important, as I said, to understand that this kind of system has really no connection to rendering or components. It's really just a system of change unto itself. But it's probably easier to show you. So I'm going to go back to our simple greeting. And now I'm going to introduce our signal midway in there. It's basically a new primitive, kind of like a promise. And the key part of it is it has a getter and a setter. So now when we access our friend's name, we actually call as a function up in the greeting. And when we update the name, we're calling it as a function. And the reason it's a function is important because we need to intercept the values. That being said, not that interesting, this example. We'd just go home if that was all that's did. So we need our second primitive, which is create effect. And in this example now, we run the effect once, and it immediately logs the name of our friend. And then when we set the name, it immediately logs our updated name. What's really cool about this approach is I can take it even further, and I can actually kind of hoist it out. I can make my friend's name uppercase for some reason. And now, as you can see, it'll log once, and it'll say, hello, John, now in caps, and same for hello, Mary. As I mentioned before, people who've seen some modern JavaScript frameworks might have seen something somewhat similar before, and they might be wondering how this works. Is it a compiler? No, it's not a compiler. It is actually simpler than that. It's a runtime mechanism using the JavaScript stack, and one that I can implement a very, very basic version in less than 50 lines of code. So we're just going to pretend that we're making this ourselves. At one point, there's a lot of concern that this kind of reactivity was magic, but I'm hoping to disavow that kind of thinking. So what do we have as signal? At a base point, we have a value that gets wrapped. So I'm using the fact JavaScript has closures for this example, that we're just returning the value every time on read, and then we set the next value on write, and we return the tuple with both read and write. And this itself doesn't do anything, so we need to add subscriptions. So I've added a set at the top that will keep track of the signal's subscriptions. Additionally, we also need to have some kind of global stack and a way to get what's on top of the stack. With this, we can actually introduce our next primitive, which is the create effect. And this one's a little bit more involved. Basically, if you look at the bottom of the function, it executes once. But the whole point is this loop inside the effect, and we're going to focus on that for a second. Basically, the way this works is whenever the effect runs, including that initial run, it pushes itself onto the stack and then runs the function provided. In our case, it was console logging upper. And when that happens, it executes the user-provided function, gets to the upper call, finally reads the friend's name underneath. And when it reads that signal, we need a little bit more code here, which is it checks if anyone's listening. Well, in this case, we know someone is listening. We just pushed it onto the stack. So we get that current observer, and we add it to our subscribers list, and then just return the value. So it finishes, console logs out our value. Then the effect kind of cleans up after itself. It pops itself off the stack, and we're done for now. At some point later, event happens or something, we write our next value, and we just notify all the subscribers, which just rerun those functions again. And that execute function, again, pushes itself onto the stack, reruns, tracks dependencies, and so on. It's just this loop, essentially. That's it. There's a little bit more complicated logic when you get into reactive graph derivations. I'm not going to get into those things. The basic concept is something that just uses the runtime stack. From there, as I mentioned, we can build these other things. If something's expensive, we can basically cache values. We call it create memo. Some frameworks call it create computed. We have proxies, which let each property be its own kind of reactive signal. And finally, we have an API for async called resources, which convert basically promise factories into a signal. I focused a lot on React, but there are other frameworks using signals. A perfect example, Vue's been doing this for years. People have been using MobX in React. But what we're doing here with Solid and some of the newer frameworks is a little bit different. It's probably easier to just show you. All right. So we're gonna do a little live coding here. I always love live coding. Hopefully you all hearing that rattling sound? Or is that just yeah. I hope no, it's probably just my earring hitting the mic. Anyway, it's funny, every time we introduce reactive programming, it's always like a hello world, kind of like, sorry, I'm like literally writing what I'm saying, console log. Let's do something a little bit more substantial here. So I'm gonna create a DOM element using vanilla JavaScript in H1, and I'm going to, get element by ID. In our playground here, we have an app element that I can use to mount, and I'm literally just gonna append our H1 to the page. How are we on text size? This seems a little bit small. No, maybe I'll blow it up one more size. Hopefully everyone can see it. Okay. And essentially, we need to, instead of console log, what if we used our effect to actually update the text content of our H1? And there we go. We can see the count is 1. And this in itself is not terribly interesting to be, and it jumped right to 1 because we set it right away. So I'm going to save myself some typing and implement a button that, again, using vanilla DOM APIs, and let's blow this up a bit, is going to essentially just call set count with count plus 1 every time I click on the button. So now we have our working counter. Of course, I don't know anyone who writes code like this anymore. Kind of gives me some jQuery-esque vibes. You're just sitting there, DOM APIs, updating some stuff. So wouldn't it be convenient if we could just, instead of writing all this like DOM code, could just like write maybe something like JSX instead? So I'm just gonna, what is it? Click me. I'm just gonna take this description of the element here and turn it into some JSX. And we can comment out this. And we can actually do the same thing for our H1 up here too. So what is it, H1? There's one little difference though. We have this effect, right? And because we know to be reactive, we have to call it as a function. That's like a base principle of JavaScript, or it has to be maybe in a getter or a proxy, like member access. We actually can kind of guess that this would need an effect just simply from the expression that's passed in. So in this case, we're calling a function. It knows to auto-generate that effect. So you can basically picture that this code generates this code generates this code, and our counter still works. Of course, again, no one really writes code like this. It's a little bit bulky, so I'm going to just move some stuff around. So function counter, kind of maybe move it into a reusable function here, and we can drop that in there and return an array of H1 and button. And then I'm just going to call our function down here and spread it into our vanilla DOM API. And luckily, I have prettier in here to kind of make this a little bit more readable, though it's still kind of bulky. Actually, let's inline this here, the H1, and let's grab this button as well. Again, we don't need to have served verbose. Kind of clean that up a bit. And instead of an array, maybe JSX has a syntax for groups of elements called a JSX fragment. So I'm just going to JS fragment's basically an array, and I'm going to format this. And honestly, this is fine here where it's appending. I mean, our counter still works, but I think that that mount point could be made a little bit nicer if we just import something called like render from SolidJS web, and then that function that we called one time can just be called one more time right here, and I'm going to get this element that I'm attaching it to, and put it here, and just delete this. It's there twice now. And I think this all works well. The counter counts, and this kind of starts looking like something some people here might have seen before. Some people have seen React. There's a huge difference, though, between what you might find in a lot of other JavaScript frameworks in this. Because if I go in here and I go console.log counter, it's pretty small, but there's a log down here. If I click this, it doesn't matter how many times I click this counter, you're not going to see that log out again, because as we already talked about, there is one effect updating the text just of that number inside the JSX expression. So there's no rerun of components. We just have this small reactive update. And this has some pretty cool implications. For example, now I've added 2 counters to the page. I'm using a fragment down here, and I have 2 counter components. And what this means is each one, again, at the beginning, we see counter now logged twice. Each one has its own signal that it basically uses in its own effect. And I click this one updates, click this one updates. But neither version logged the counter again. And it should come as very little surprise at this point that if I just grab the signal and hoist it above my function, that they would now just both reference the exact same instance, and now we basically have what one would call global state. I'm going to take this example just one level further. What if we have a hierarchy of components where we have like an app component that has our state, and we're passing it into our 2 counters. In this case, one counter increments the count by 1, so we're passing a click handler to it, and one increments the count by 2. And then one shows the count, and the other one shows the count times 2. I'm just playing around with it. What you see at the bottom here is that app gets logged once, and counter gets logged twice on that initial render, like you'd expect. But the fact that the state's in the parent, that they process it different, read it different, won't matter, because even as I click both of these, you're not going to see any more console logs, because nothing's changed. We just have, again, 2 effects, one for each of those text nodes. It doesn't matter how many components we add or how many levels we pass the props down. Those are the only things that change. All right. OK, so maybe I didn't tell you everything. How does that work? The key to it is, in the same way when we see the function call on like normal native elements and wrap it in a crate effect, well, when we see the function call getting passed down as props to our child components, we just wrap it in a getter. And just like that upper example at the very beginning, where I wrapped it in a function and called it inside the effect, it just still is using the runtime stack. We just defer reading it until it's inside the renderer. So we kind of flatten the whole component tree, and props basically pass through the whole thing without ever re-rendering any components. There is one other caveat I want to mention. We were returning real DOM nodes, right? I was just using vanilla JS and just like attaching divs, and that's all fun. But what if you have to deal with a list like that in that to-do app? It's kind of expensive if every time I change the list, I'm going to recreate all the list elements. That would be very wasteful. So I built a reactive helper function. But then I thought for a moment, and I realized, well, what's the pattern of composition inside all these frameworks? Well, it's components. So in Solid, we ship a 4 component. And we like this because it's very composable. What do I mean by that? I mean, sure, this is the base pattern. But now, pretend you have a new requirement. You have to show a paginated list. So you go in NPM, install a package, and I mean, what does it look like? Well, you end up just doing this, right? Your 4 becomes paginated. And truthfully, it could also become a virtual list for virtualization. Your conditions could become, I don't know, layouts, error boundaries, suspense. These are all basic mechanisms that we rely on with components. And the thing is, if you don't like this 4 component that comes with Solid, you can write your own. It's completely runtime. the mechanism here. The only thing that gets compiled is a consistent rule around how we handle the reactive expressions in the JSX, like the props I was talking about. So armed with this, actually, we can go back to that original example that I showed at the beginning from that React conference where they were talking about how they're going to use a compiler. And the interesting thing to me, and this one also needs to be blown up a little bit, is essentially this looks a lot like that original code example at the beginning where we got some state. In this case, I'm actually using solid store, which is the nested proxy. We have our state handler, but what's different is this is actually the final version of the code. We have the filter on the visibility getting passed in. We have the theme getting passed in to our add to do button. So essentially, even though, and I've got some console logs to prove it, like whenever the filter function is called, I like put like a console log at the top here, like filter gets called. Whenever someone updates a to-do, I actually had to inline the console log. It's a little tricky to show what has changed in this case because so little does, because we don't rerun components. But if I go here and click, one of these, it's going to now increment this like to 4, like originally it was 3. If I switch the filter, it's going to call filter. If I switch back, you're going to see the filter call again, and the one item that was missing created again. But if I do something like take this theme color here that's passed through from props from above and just go crazy here, you're not going to see any more console logs. And that's because all the state updates are completely isolated just by the nature of writing using signals and reactivity, right? And so the big part about this example is what's not there. What's not there is there's no dependency arrays. There's no use memo. There's no react.memo. There's no use callback. And there's actually, the compiler actually only touches your JSX. It doesn't touch any of the code you wrote. It's completely transparent. So I call this, sorry, I went too far. I call this the reactive advantage, right? So components run once, so there's no hook rules or stale closures. You don't have to worry about that. Templates compile to real DOM nodes. This is super low abstraction, right? Like if you've ever had to incorporate like another third-party JS library, you literally like div is a div. You can just like grab it. And most importantly, state is independent of components. Component boundaries are for your sake, how you want to organize your code, not for performance. The performance is good regardless. And I really want to emphasize this last point, because it isn't about the raw performance and benchmarks. It's that components just aren't a consideration when trying to optimize how your code runs. Component-based runtimes tend to either be really lightweight, but lead to a ton of re-executions, like React, or they make the component boundaries the boundary of reactivity, and you pay this overhead based on how you break apart your components rather than how state flows through your application. Both of these push you to make either more or less components, just to satisfy the framework. And yeah, I mean, there's tons of examples of why this is a problem, right? For example, too many components can lead in needing to pass too many things through, right? Now you have something called prop drilling, where you have to like keep track of how your props go all the way through. And similarly, too few components can lead to excess over-execution, which is a performance problem. The thing to take away from this is UI tree and state tree should be interwoven, but they aren't the same thing. So I guess I could kind of sum it up like this, right? I showed this from my demo a moment ago, right? It's all the same mechanism, whether you have local state or global state. Which kind of, I told you we'd come back to that compiler. If you aren't careful, you no longer have the language to represent certain ideas. If your whole world is a component, then how do you represent what lies outside of it? This is just illustrative. There are solutions. A lot of frameworks that are component-based end up having like a second state solution to handle global state. Svelte has stores. React has, well, a lot of options. But I do want to impress that compilation is definitely an important tool in our disposal. And I do want to expand on that a little bit, right? Because to me, this is part of a larger trend. I may have used Solid today to illustrate it, but this is just the beginning. Reactivity already has been serving as a common language between UI frameworks to a certain degree. Like Solid obviously has signals, but Vue has had it for a long time, kind of hidden behind their option API. But recently, Preact, Quick, Angular have all added signals to their frameworks. And what I like about this is even if you squint a little bit looking at these examples, you actually see the same language features in things that don't use signals, like Svelte or React. As mentioned, there's differences, but there's a convergence here on a language level. And to see this consolidation is really exciting for me. Because honestly, it probably shouldn't come as a surprise that powerful primitives at a language level could unlock incredible capability in what their ability to compose, right? I mean, it makes them the ideal target for compilers, or maybe even used by AI. An interesting trend recently has been that since that talk at the beginning that I was using, talking about auto-memoizing compilers, they've updated their language now in the React team to talk about auto-reactivity. It isn't only that memoization is insufficient to solve the performance consideration, it's that with implicit memoization, it's a lot harder to explain the mental model, right? What do I mean by that? Well, pretend you have a bunch of code that just looks like plain JavaScript that runs from top to bottom. How can you, does it still feel like it runs top down if only certain parts of the code just happen to run? This is a fictional situation. No one knows how the React compiler is going to run at this point, but I just wanted to kind of do this mental exercise, because when I was working on Marco, we had a very similar kind of concern, because pretend you put a console log in each of these functions. And this is just like a simple setup where you calculating, maybe you went to a restaurant, bought a bunch of food, calculating the total, and then you're calculating like a federal tax and then like a local tax. And obviously, the first time this runs, it'll run and you'll get 3 console logs, right? You'll get the one for the subtotal, you get one for the tax, and you get the one for another tax. But the question comes in, what happens with this code when you go, oh, I'm in the wrong state or whatnot, and you just switch that and you only change the state tax rate? Well, if it was most frameworks today, it would just rerun everything, you get the 3 console logs, and you see the output. But would it be strange if just the last function just happened to run? Now, I've inlined it so it's very clear to see that only that function depends on the state tax rate. But it could also, this could have all been inlined, like just a bunch of logic inside your component, and the compiler just decided, oh, these lines of code need to run, these other lines don't need to run. And it's kind of hard to actually explain. I think it becomes difficult to explain it top down. In fact, you might start talking about data dependencies changing. And honestly, if you've used React anytime recently, like hooks or whatever, you're familiar with talking about data dependencies. And this is where I'm getting at. You might even describe this as being reactive. It's not about memoization anymore. So what I'm getting at is, if we're going to do this anyways, we're all going here, why not apply it beyond component boundaries? We've seen this working with Solid. Vue actually announced that they're working on a new compiler recently called Vue Vapor. And if you can see this code at all on the screen, it looks really similar to what we were just live coding. But it doesn't stop with performant, good DX in our client-side applications. I've been talking about the cost of components for several years now, but recently we've seen applied in new ways. Components that rerun means you need all that JavaScript in the browser, even after server rendering. This reboot, known as hydration, is basically when a server-rendered application starts up, it needs to rerun all the code to attach the event handlers and whatnot, is a function of our component model. We didn't have this problem with jQuery. But if you get rid of runtime components, you also can eliminate this hydration. It's been realized by a lot of multi-page app frameworks, things like Astro, or to a certain degree with partial hydration and islands. Things like Marco from eBay, Builder's Quick. And we've been playing around with this a bit recently because we wanted to apply it with client-side routing in Solid's meta framework, Solid Start. See, the problem is this. Now, this is not everybody's problem, but single-page apps scale linearly with components for the most part. But interestingly enough, fine-grained reactivity means execution scales with interactivity rather than DOM size, right? In Solid, even though I showed those separate create element calls, what we actually do is actually clone all the HTML elements together in one go, and then walk and then apply the create effects on them. And what this means is if that page is already server rendered, we don't need any of the DOM code. We just need the effects to update the DOM that's in place. And it's a bit like, I get, like, who cares if you're not, in an e-commerce site? And I'm a little biased. I said I worked for eBay for a few years. But the thing is, it doesn't matter the framework. And to a certain degree. Svelte actually starts as the smallest framework and ends up being the largest in this kind of comparison. But most of the other frameworks actually have a fairly similar slope. You get more components. It makes a way bigger difference than the initial size of the framework at the beginning. This is where you're going to sink in your cost. So we've been playing around with that. So I got another demo that I want to show here. Luckily, the Google Chrome team has been kind of nudging all the frameworks towards, better web performance. And they've been working on this thing with, I guess, this Taste.js Movies app, which is implemented in a lot of frameworks. A lot of the meta frameworks, things like Next.js, Nuxt, Angular, Lit, SvelteKit, QuickCity, Solid Start, and Astro, if I haven't mentioned that already. And I was like, it was an opportunity to try out this new experimental approach that we're having. When I say experimental, I mean anyone can go use it. You just have to turn it on. And I was pretty happy with the results. So I'm just going to quickly show what I'm talking about. See, this is the Movies demo app, which hopefully I have decent internet connection in here. It'll do. But essentially, even though it looks like browser affordances when we're moving around with these loading states, this is not spinning. This is a client-rendered app, more or less, and we're just navigating around on this page. In fact, we grabbed this demo straight from Nuxt. Of course, it's not going to load right now. Oh, there we go. OK. So apologies on the internet side of things, but you can see that this is basically the same demo. It's been made slightly different in each framework, but this is the baseline. So it even has a search functionality where you can go in here and what am I going to do? House of, you can do this, and it's single page app kind of functionality. And what's interesting about this is if you look at this page, you might not think very much of it being different than any other kind of simple, single page app kind of page. But what was really interesting is this one. How much JavaScript does it take to build an application like this? I don't know. Well, apparently 13 kilobytes. And even if I click into the details, well, it's still 13 kilobytes. I guess when I go into search, it'll be a little bit more. What do we got here? Yes, it loaded another kilobyte for the search functionality. Let's search something. Let's go do that again. No more JavaScript. We stopped at 14 kilobytes. And the reason for this is I mentioned before Solid scales and reactivity scales basically on interactivity, not DOM size. Well, what if our APIs returned HTML instead of JSON? If we could do that, we'd only need to send the JavaScript for the parts of the page that were interactive. And if we can do it for further navigation, we could basically, even with client-side routing, never send the vast majority of the website to the browser. OK, so as I said, there's only a couple technologies that are out like this. This is basically like React server components if they were small. And what I mean by that is, let me get back to my presentation, is I did that exact same exercise we just did in a bunch of frameworks, just to kind of understand the impact of how big this kind of migration is, like how fundamental this changes things. Because let's face it, Solid Start would probably be a lot like SvelteKit. We're neck and neck always on all these things. I think Solid Start's version would be about 29 kilobytes, but that's not what we're focused on. Svelte does an incredible job. The average thing that people are building, in your Next or Nuxt sites, for a very simple application, it was 190 in Next. It's close to 100 kilobytes actually in most frameworks. I was actually a little worried before this talk because React Server Component version came out. And as it turned out, it's actually the same size. It actually did not impact the next demo. You can go check out the Taste Movies app if you want. So what else? I'm going to really push this one hard. So it's more than about just sending code to the browser. It's a part of bigger trends that we've been seeing towards monolithic authoring with distributed deployment. To leverage how we can distribute compute between edge closer to user, regional data centers closer to databases, or even build time, we need new tools and new ways to break apart our code. What about service workers and web workers? How about dedicated? This is so awesome. What about dedicated environments for more expensive compute? Like, what if you got like what if you had like some GPUs somewhere? The automation infrastructure as an extension of monolithic application authoring is very much on the near horizon. And we keep seeing the same concerns about how to break code smaller and how to communicate between those pieces. You see what I'm getting at? It's kind of same pattern. Honestly, I could go on for days. OK, fine. Actually, I've got one more. What if you can not only visualize your component tree with dev tools, but actually trace the data flows? Oh, that sucks. It doesn't look like the video is going to play. I should have made it into a GIF. Oh, well. What you would have seen is SolidJS's debugger, which allows you to not only view the component tree, but look at when you update a signal, piece of state somewhere high in the hierarchy, see exactly where it updates in the UI. This is really cool stuff in terms of the potential of debuggability when you have the power of knowing how everything in your app is connected. OK. Yeah, it's not going to play. So it's not about VDOM versus not, or about diffing or not. You could embed a virtual DOM inside a reactive system if you wanted to. You can do concurrent rendering without a VDOM, and time slicing and all the fun, fancy stuff. We have those features in Solid if you care to use those. It's about recognizing that our change model, while very much entwined with our UI representation, is not the same thing. For this reason, the conversation around the world beyond components starts with reactivity, a system of change unto itself. Reactivity is already everywhere in JavaScript frameworks, from state management to compilation, but we can leverage it best if we fully embrace it and live in its declarative world. So maybe a revolution is not in the cards, maybe just a reactive renaissance, but I mean, who knows what's just one step away. Like what you saw today, you can find all the resources you need off solidjs.com. You can also find me on Twitter. And if you really like nerding out in JS frameworks, I usually stream every Friday for up to 5 hours. I apologize. I don't think the stream starts till about 8 p.m. Portugal time. But I am there, and all the videos are on YouTube. So thank you very much. It looks like I do have a couple minutes for some questions if anyone wants to ask. Yeah, so the question is, how do I see using signals in something like React Native? Yeah, I think it's actually, it's completely, it's interesting. You could, there's two possible questions there, I guess, right? Are you talking about React Native specifically, or just in native code development with JavaScript? Just
I'm talking like in React, you have the separation of the reconciliation algorithm that is used on CLI tools, on React Native, etc. Do you see a future where Solid can have this separation so that technologies like this exist?
Yeah, we already have this feature, in fact. We have custom renderers in Solid. We've ported 3JS, Ink, what's the other one, a PDF one. The people, I have to admit, haven't been really starting up the native port. It's an incredible amount of work. And like they have full teams at Meta working on it. this is not a limitation of the technology, it's just a limitation of manpower. Some people have applied stuff like this to like native script, obviously, but the custom renderer and stuff is not something you need a virtual DOM to. The reactive tree, as it turns out, is completely independent. Like in my code examples there, if you did not put a native like H1 or div element in the code, there is no native DOM code in the whole thing. It's just reactivity, updating reactive props that are just triggering it. So yeah, the custom renderer can put the reconciliation and even object creation completely back in the hands of whatever native platform.
Thank you.
So.
Hello. Hello. From your perspective as a framework creator, how do you see this new trend of no kilobytes frameworks that make all the compilation and just output?
Yeah, it's an interesting thing because any real app is not going to have 0 kilobytes. I think the 0 kilobytes thing's got hyped a little bit too far, and the fact that even you can lazy load it. What you actually ideally want to do is load some minimal amount of JavaScript at the beginning. 0 is not a very important number. You're going to bring the framework in, so might as well bring in the whole framework. Might as well bring in any of that initial code to do interactivity on the front of the page. Like, there's going to be stuff you want to lazy load, expensive stuff. For the most part, there's lots of ways, like some that I even showed today, of just reducing the amount of code that gets shipped to the browser without necessarily going to 0. Like, if you can reduce, a lot of pages, maybe 60 or 70% of your code, simply by doing, kind of partial hydration, like islands type mechanisms. The fact that those islands load right away or not is only relevant if you, like, say, have something very expensive on the page. A lot of the work that we did on eBay was making those pieces smaller, but the lazy loading aspect, or like the initial 0, was not really in our interest. And similarly, if you look at stuff like React with their selective hydration, again, it's all done eagerly because you're going to need the JavaScript you're going to need. So with the exception of very expensive things, I don't think it focus too much on the 0. The only thing that I do like is I think there's some benefit to the opt-in mentality, right? It's the same thing with the signals, like you're opting into change. The same thing with these, 0 KB things, is you're starting from a baseline that's more realistic and you're building on it. I think that's where the real value comes in. If it's any more, I got like another minute or two, but otherwise. Okay, perfect. I'm done. Thank you very much.